Hi, this is example number 3 of section 12.8. So if we read the data that we are given, so due to the rotation of a forked rod, the ball travels around the slotted path. So where that cardioid shape is given by this expression right here, is described by this expression, which is 0.5 times 1 minus cosine of theta. Then, and theta is given in radians. So for theta equals 180 degrees, so we are in this part of the figure. So the fork has already traveled 180 degrees. The velocity at this point is 4 feet over second, and the acceleration is 30 feet over second squared. And we are asked to find the angular velocity, so this angular velocity, theta dot, and the angular acceleration, theta 2 dot. First of all, we have to decide which kind of coordinates we want to use. Since we are given information in terms of r and in terms of theta, I will use cylindrical coordinate. If we recall, the velocity in cylindrical coordinates can be written as r dot in the direction of the r expression. So let me draw this is r, and this is theta, right? U theta and u r, right? And then I keep going, writing the expressions. I don't expect you to learn this expression by heart. You have it in your formula sheet. I do expect you to know where it comes from, and the explanation where these expressions come from is in the non-rated lectures. So please review that. Okay, so those are the expressions for the velocity and the acceleration in terms of cylindrical coordinates. So what do we have? We have r equals 0.5, 1 minus cosine of theta in feet. Therefore, we have r dot will be equals to 0.5. The derivative of 1 is 0. The derivative of cosine is negative sine, so we have sine of theta. And we cannot forget that we are deriving respect to time. And theta changes with time, so we have to put the internal derivative, which is theta dot. And that will be feet over second, right? And then we can derive this expression, and it's the derivative of a product. So when we derive a product, we have to remember that we derive the first term. The derivative of sine is cosine, so we have cosine of theta times theta, right? And this is the internal derivative times theta, which is that one. And now we derive the second, which is this one, which is 0.5 sine of theta, theta 2 dots. And all that will be feet over second square. We can evaluate that for 180 degrees. We will have that r is equals to cosine of 180 is negative 1, so it will be 2 divided by 1. R is equals 1 feet. R dot will be equals to sine of 180 is 0, and R 2 dots is equals to, this expression becomes 0, and we evaluate that way as a negative 0.5 theta dot square. Okay, and this is feet over second, and this is feet over second square. Okay, so we have these three expressions. So we have this expression, this one, this one, this one, and this one. So we are missing theta dot and theta 2 dots, and that's actually what we are asked to find. But we do have the velocity and the acceleration, the modulus of those. So since we have the magnitude, so what we do is we recall that the magnitude of the velocity which we have will be the square root of each of these components. So that will be r dot square plus r theta dot square. which is then, this is given, which is 4 equals 2 square root of r dot, we found it is 0, plus r theta dot, and theta dot we don't know, and r is 1, so we have theta dot square. From here, we can actually solve for theta dot. We notice that theta dot is equals to 4 radians over second. And we do the same to find the angular acceleration. So we know that the angular acceleration will be the square root of its component. Since the components are those ones, well, we will have r2 dots minus r theta dot square plus theta 2r dot theta dot plus r theta 2 dots square. And that we know that this magnitude is also given, is 30 equals, and then I plug out all the values that I do have, square root of. So r2 dots is negative 0.5 times 0.5 times theta dot square, which is 4 square, right, minus r, which is 1, times theta, which is 4, and all that square. So I have to keep going with my square root right here, plus. Now this term will be 2 times r dot, well, that's 0. I'm going to write it, so just theta dot, which is 4, plus 1, plus theta 2 dots, which is what I'm trying to find. Multiply all these numbers, and the only unknown in this expression is theta 2 dots. So solve for theta 2 dots, and it gives me the value of 18 radians over second square. And this is the solution of this problem.